a out, and I get a times a minus 3. And then sub back in what your a value was. So I get sine of x minus 3. 609. Okay. I'll use the same substitution for the next one. So this will end up as 4a squared minus 1. What type of factoring is that? Difference of squares. Because you can square root everything. So it turns into 2a plus 1, 2a minus 1, which is really just 2 sine x plus 1, 2 sine x minus 1. So if you see two terms separated by a minus sign, that is a big screaming at you that it's a difference of squares. As long as everything's square rootable. That's an word. Can be square rooted. All right, the next one is more of your standard factoring that you're used to. Trinomials. So it's got cosecants. I'll get rid of those or use a is equal to cosecant x. So I end up with a squared minus 3a minus 28. How do you factor something like that? Nope, you don't make it. We're not trying to solve it. What? Yeah, so what multiplies to negative 28 and adds to negative 3? There you go. Negative 7. Positive 4. And then just sub back in your trig function. We're not solving. This is just factoring. We'll do one practice question, then we're going to start to solve them. I just want to review factoring because it looks a little different when you put trig functions in it. Next one. Again, I'll sub out the cosine just so it looks a little better. All right. So, anybody remember how to factor these guys? So you can use the window method or you can use decomposition. Window is essentially decomp. It doesn't matter to me how you factor it. The way I do it is I go 2 times negative 4, multiply the first and the last, and you get negative 8. And then you ask yourself what multiplies to negative 8 and adds to 7, the middle term. Negative 1 and 8. So that means this middle term gets broken up into negative a plus 8a. Yeah, like if you add negative a and 8a, it adds to 7a, right? And then you put brackets around the first two and factor something out. In this case, a. 2a minus 1. Do the same for the second two. What can I factor out of 8a minus 4? 4. And I get 2a minus 1. You know you're probably doing it right if the brackets match. If the brackets are different, you've done something wrong at some point. And then essentially you factor out a 2a minus 1, and you're left with a plus 4. And then plug back in your trig. Now, like I said before, you don't have to substitute out the trig. If you can do it without doing that, it's a bit faster. Saves you an extra step. And that is factoring trig functions. It's the exact same thing. It's just one more level because you have a cosine, sine, tan, or whatever in it. Trig function. Okay? So it's 2 cos x minus 1, cos x plus 4. All right? You got 5 minutes to do question number 1, please. before we move on to solving these things. Okay, people, it's page 610. Here we go. So, we're solving our first quadratic trig function. 2 sine squared x equals 1 minus sine x. Okay? Get rid of all the trig functions first. I'm not going to do this on every question, and I won't show you the factoring on every question, but we'll do it for the first couple. Okay? So, you can sub out the sign by going a is equal to sine x. So you get 2a squared is equal to 1 minus a. Okay. Right now it's a grade 11 problem. How do you solve that? How do you solve a quadratic equation? There you go. You move everything to one side. So I'm moving the a and the 1 over. And I get that. Now what do? You factor it. So 2 times negative 1 is negative 2. What multiplies to negative 2 and adds to the middle term positive 1?
2 and negative 1.
2 and negative 1. So I break up the middle term. I get that. You bracket the first two. What's a common factor of in the first two? 2a comes out, and I'm left with a plus 1. What can I take out of the second two? Negative 1, which flips the signs. So then you're left with 2a minus 1, a plus 1 equals 0. Okay, that's grade 11. All right, then you would factor it. Or sorry, solve it. How do you solve a quadratic from this point? You set each bracket equal to 0, right? What's wrong?
I don't get what you did like on that top step to get to that bottom step. Like 2a squared plus a minus 1 equals 0, and then how do you get to whatever's below it?
I rewrote this a
Yeah.
as 2a minus a, because if I subtract those, I get a. And I got those numbers by multiplying the first and the last.
Oh, okay.
Okay, you got it?
Yeah.
Okay.
So the term in front of the a squared will multiply with the last term. So if there's a term in front of the first squared,
It is 1, yeah. Okay. So essentially, you would rewrite it like this in grade 11. You'd say 2a minus 1 is equal to 0, or a plus 1 is equal to 0. Which really means a is equal to negative 1, or a is equal to a half. But we're not solving for a. What is a? It's sine x. So you have to put that back. So I'm going to do it over here. So really what you have is sine x equals a half, or sine x equals negative 1. That's just like the stuff we did in trig 1 and yesterday. So sine x equals a half. What's my reference angle, and what quadrants are we in? We're going to be in 1 and 2 because sine is positive. What's the reference angle? It is 30. So your reference angle, you can either do the inverse sine, or you can use special triangles. Doesn't matter to me. So those are 30. So what's the rotation angle there? 30 and 150. They want it in rads. I put all of them on the board over there. And how many 30-degree angles are in 150? 5 of them. So 5 pi over 6. So there's your first two answers, but you got to solve the other one as well. So where's sine negative? You're in the bottom two. What's your reference angle? So your reference angle is going to be 90, which means, whoops. Where are you? Yeah, you're right there, right? Which means the rotation is x equals 270. Anybody tell me what 270 is in rads? Three pi over 2. Okay, so you can do it that way. If sine or cosine equals 0 or 1 or -1, you don't even have to do that. If you know the graph, there's a sine graph, right? That's 1, that's -1. This is saying, where does sine equal -1? Right there, which is 270. Okay, so if you know the graphs, you can just do that quickly without doing any of this stuff.
Wait, so would the answer be x equals pi over 6, 5 pi over 6, and 3 pi over 2?
Yes. Okay. So yeah, that's the next step. The final step is, what does x equal? It equals all of these. So it's pi over 6, 5 pi over 6, 3 pi over 2. So those are all the possible answers on the domain 0 to 2 pi, or 0 to 360 if you want. Okay? Now, they're asking for the general solution. How do you get the general solution? Yeah, you add multiples of the period, right? So all you do is you take those three, and look, because you're going to see some of them have a lot of answers, you can just go like this. Whoops. Write them all out and just go plus n 2 pi. That's acceptable for me. Probably not on a university test, but we're not in university yet, so. Plus this. Yeah. We won't solve questions like this next semester. And you're right, I am not in charge of the test if you're in Math 100. So. All right. Any questions about that? It's the exact same thing that we've done. The only difference is this first part where you have to factor. But once you've factored it to here, it's the exact same as the trig 1 stuff. Okay? So let's do a couple more here. This one, 4 sine squared a minus 1. They're going to want the general solution and the answers between 0 and 2 pi. What is my first step here? Substitute. Okay. You want to make it b? Okay, so I'm going to show you a couple different ways to do this one. So b is equal to sine. Yeah. So you get 4b squared minus 1 is equal to 0. So you're going to get 2b minus 1, 2b plus 1. So you end up with 2 sine a minus 1 equals 0, or 2 sine a plus 1 equals 0. So you get that, right? Everybody with me up to this point? Okay. There's another way to do this type of question, okay, where you don't actually have to factor it. We've done this before, actually. So when you have a single trig function like this, I can go like this. Sine squared is equal to 1/4. Does everybody see how I got that? Now, square root. If you square root it, you get sine of a is equal to 1/2. But when you square root, what do you need to remember? Plus or minus. So I get, let me erase that. plus minus a half. Is this the same as that? It is. Okay. So it's a bit quicker. You get it to the same spot though. That only works if you have a single trig function though, like this. If you have multiple trig functions or two of the same, like it's a something like that, or what we did up here, that's not going to work. Okay. So we're in all four quadrants. Let's just finish this question quickly. What's my reference angle? Sorry? 30 degrees. Does that make sense for answers? Okay, we have to write them in rads though, because they want the answers in rads. So what's 30 in rads? Pi over 6. What's 150? How do you write the general solution? All of that plus n 2n pi or n2 pi or whatever. Same thing. Yeah. No, exactly the same thing. So you just do that and you go n2 pi and you are done. So this, just take your answers and write plus n2 pi. Is that good? Okay, let's do a tan one. Tan squared x plus tan x equals 0. What am I going to do here? Okay, you can substitute. I'm not going to actually substitute on this one. If you want to, you can. But how do I factor that? Factor out a tan. It's the only thing you can do. You've got two terms. So I'm just taking out a common factor of tan of x. So I've got that. So then you have tan of x equals 0, or tan of x is equal to negative 1. Exactly. It's like having just an x by itself on the outside, right? Okay. Let's do the tan x to the minus 1 thing first. Where is tan negative? Where is tan negative? 2 and 4. Boom. Boom. What's my reference angle? Nope. 45 degrees. So what does x equal for this one? 135 and 315. So there's the two answers for that one. Now, tan of x equals 0. What's your reference angle here? Which means, exactly, you are here, or there. So x is equal to 0, 180, or 360. There's another way to do that one. When you have a trig function that equals 0 or positive or negative 1, excluding tan for the positive or negative 1, but especially 0, if you know the trig graphs, you don't have to do any work. Where does tan equal 0? 0, 180, 360. All right, it's saying where's the x-intercepts? That's what it's saying. No, you can do it for sine and cosine where it equals 0 as well, because it's just the x-intercepts.
So for existence, if for some reason, like in this question, if it wasn't tan, it was like say cosine, that means it would be.
Where's cosine equals 0? 90 and 270. So if it equals 0, you can use the graphs. You can still do this, like this method that we do here. You can just do that every time if you prefer that. Okay. All right. So all my answers, the answers for this question are 0. I guess we'll go in alpha or in numerical. Yeah, I'll do it in a sec. So there it is in degrees. You list them all. And then, excuse me, in rads. What's 0 in rads? What's 135 in rads? It's a multiple of 45. 3 pi over 4. What's 180? What's 315? 7 pi over 4. 7 45-degree angles. What's 360? There you go. How do I write the general? Huh? N pi. What's the period of a tan graph? Pi. So that's the trick that people will get. You know I'm going to ask you a tan question. You just know that. Okay? So the trick is all of these. 7 pi over 4. 2 pi plus n pi. There is a shorter way to write it, but we're not going to do that unless you really want to. Boom. Look at the math. There you go. So the short way, if you see it, is n pi and 3 pi over 4 plus n pi. That would be the short way. All right. Are we okay with this so far? We're just, the only real new stuff is the factoring part. This generates more answers. That's it. Okay, we're going to do one more. And then I'll release you to the hounds. We're going to do B. So, factor that. I'm not going to do it. I'm just going to put the answer up in a sec, but you got to do it right now. So, please, factor it, please. Not F me. I'm going to put that in your reference letter.
I hope not. That's about par. Yeah. I got a deep fried pickle. Why would you do that? Why? What is that? Yeah, I know.
You're just factoring it. Factor it first.
What's the date? Are we?
What is what? Doing this way.
Yeah.
Factor this.
Oh, okay, just factor that.
Just factor
Are
that.
we doing A or can I use that space?
You can use that space. We're not going to do A.
Well, you have 6 and negative 1. Yeah.
All right. So once you're here, let's do the cos equals -3. Is this the one that's blowing up on you, Talia? Yeah, okay. Why is it blowing up? Because if you do this and you try to find the reference angle and you do this of that, you're going to get error. The reason you're getting error is because on a cosine graph, what is the maximum of a cosine graph? 1. What's the minimum? -1. So when you write cos theta equals -3, what you're saying is, where does it equal -3? If -3 is down there, does it ever equal -3? No. So the answer is error. No, it doesn't exist. There's no answer from that half of the question. So you just ignore this. You can just ignore that. You have to show that work. All right. On a test, I'm going to want you to show this and then just say error or it doesn't exist or something. Okay. So you only have to really deal with the other side. Cos theta equals 1/2.
So is error one of the answers?
Error plus n pi.
Can you walk into like a grade 9 math class and write a question and then at the end just write equals error? Just for that, and I want them to just question reality.
I think no solution is a better way to say things.
Oh yeah, that's a good one.
What is the answer? No solution.
Not even
Their heads would just be. You just made a mistake. All right. So for cosine, the reference angle, either doing it on your calculator or using the special triangles, is 60. Now, once you have that, you have to look at your domain. What is the domain here? Negative pi to pi. So you go to 0. Negative pi means you're going this way. So what's my answer from that direction? Not negative 60 degrees. Because the domain is negative pi to pi. And if you go the other direction, it's 60 degrees. If you write them in rads, it should be negative pi over 3 and pi over 3. And it doesn't even ask for the general. So you're like done.
So if the number's over 1.
If you get a trig function, only sine and cosine. So if you get a sine or cosine here that is over bigger than 1 or less than -1, all right, it's always going to be error.
Yeah, so like it's not like this.
You can because they rise forever, right?
Oh, I get what you're saying.
Yeah, if it's tan of 90, yeah, then that's an error too. Yep. Okay, is that okay? Factor. Once you factor, set each bracket to 0. Solve each bracket just like we did before. If it's asking for the answers over a certain domain, you just list them all. If it asks for the general solution, take all the answers from 0 to 360 and just go plus n 2 pi or n 360 if it's sine and cosine, the period, or n pi or n 180 if it's a tan graph. Okay? Here's what you're doing. Number 2, B and C. Number 3, A. 7, pick one, don't care. 8, pick one. And just because you love them so much, have a look at number 13.